Let's move on to the next part, numbers. Numbers is one of the basic data types I introduced to you in the previous lecture. At this moment, you should know how to assign a number to variable and how to use numbers and variables to write more complicated expressions. In this part, we will learn more about numbers in Python. Python has three built-in numerical types, which has an integer, float, and complex. For integers, Python even supports large integers. That means you can input a very large number. For example, you can input a number like 1, 2, 3, 4, 5, 6, 7, 9, 8, 0, and you can repeat it one more time, and this the type is an int, still an int, and a is a very large int number. And even you type a small number like this, this is an int. You also can use a binary input. Binary inputs, as I tell you, like the a equal to int, and you put it in a string 11110, and the base 2 is equal to 60, so a is 60, and the type is an int. This function is the way that we input a number in a specific numerical space. You also can use a hexadecimal with the int function, like how to say, you can change it here to 0x and 3c. This is a hexadecimal of this bit, so you can try to convert it yourself. Here I change to the base to the 16, and it's still equal to 60. Okay. Actually, Python also supports hexadecimal input directly without using the int function, so that means you can input it directly 0x and 3c, something like this number. It's a very large number in this table, you can see here. So you enter this, you can see a equal to 60, and it's still an int. For float, Python support the E notation. So the E notation is a notation for very large or very small number, like m, e, n. Then this number will equal to m times 10 power by n. So that means you can see here there are many very large numbers like 32.3 E18, something like that. So for example, you have like a number 3 E6. So this is 3 million, right? And you can you also can have 1 E minus 3. Yeah, that is interesting, right? Python also supports complex number as a native data type. You can input a complex number by a summation of two float number, one for the real part, one for the imaginary part. Please make sure that you put the character j at the end of the imaginary part. So for example, z equal to 3 plus 4j, and you see this number z equals to 3 plus 4 e, right, for I, right? And you can see the type of z is complex. The part, note that you can use an e notation for the real part and the imaginary parts as well. So that means the z here you can put even like 3e minus 1, 4e minus 1, and you see, yeah, so you can use this e notation inside the complex definition. The next thing is the mathematical functions and constants. So Python has many useful math functions and constants. Example here is this abstract, the exponent, the power, the max min, and so on. There are many useful functions that you use it frequently in doing math. So for example, you let's say you do the square root of 4. Oops, sorry. So you can how to say, you cannot use the function if you don't import the library. So this is like a separate library Python has. It's a built-in library that Python support. So you only can use these things, this function, by importing the math library. So to do it, you have to use a import command. So for example, here we want to import the math library, so we type the command like the math. From math we import star. So star here is a wildcard character, means everything. So this command means from the math library you import everything. So after you execute the import command, you can use this function. You can use this function, for example, like you can use the square root 4 now is equal to 2, right? And you can do like a log of 10. Oh, sorry, log of 10. And you also have the the constant pi and the e, and you see the log e is equal to 1, right? Okay, that's interesting. The math library is very useful and interesting, right? I recommend you to spend some time to practice this because we don't have enough time to do here. This one you can import the function and you can do it yourself. Yeah, practice make perfect.